Hey John, and I have master degree in financial mathematics and from University of Dayton. And right now I'm the data analyst in marketing team in engine company. To learn this class is help me to improve my skill set in analysis field, and also I learned a lot of big data tools and softwares, and I think it's very helpful in my work and also the future career. So today I'm going to present my final project. My final project topic is the big data case study uh, in marketing new home sales forecast in United States with decision tree model. The objective of this research is to examine the relationship between new home sales and market condition in United States. And to predict new home sales using decision tree model. And this microeconomic factors I selected is pricing index, consumer price index, interest rate, GDP growth rate, population, and household volumes. So the decision tree will split data into groups and predict target variable based on decision rules. So the goal is I will use this decision tree model to predict new home sales in United States on the different market conditions. So the technology I used in this final project is the hardware is a Cloudilla Quick Start VM, and the tools is the PySpark, which is the Python API for Spark, and Hive is the data warehouse in Hadoop, which provides data summarization, querying, and analysis. And the other one is R. R is the public source. It's a free software environment for statistical computing and graphics. Also, I use machine learning toolkits, which is Spark machine learning library. Its goal is to make machine learning scalable and easy. And also RPart, which is R's machine learning library, recursive partitioning, and regression tree. The data source I use in my model is new home sales, HPI, unemployment rates, household estimates, population, and GDP. And these are downloaded from the United States Census Bureau, SP 500 ratio, census.government, and the World Bank. So the first step is clean the data. The data downloaded from the website is all in Excel format. So I transform this Excel into the CSV format, and then copy this CSV into the quick virtual machine Cloudilla Home, and then load the data into Hive and create one final combined table for modeling. So here I can show the table I used. Virtual machine. In Hive, you can see these are all the script I used to create a new house sold, and I downloaded the data from my home Cloudilla final project data, new home sold CSV, and the same for all the other CSV files. And then I created the one table project data 1 and select all the variables I need to use in my model from this from all these tables based on their key variables is period. And then I create the final table and select these variables, and also I use the from this project data, and I did some calculations for each variable because they are in different. For example, the population in the table is is not in thousand, but the actual number is in thousand. So I just times 1,000 and the population new. So these are my tables for the model. So once I have the final tables for the model, then I can transfer the data from the Hive into Spark. So before this, the first thing I have to do is I need to type from PySpark import Hive context in, and now I'm ready to query the Hive table. Select the data from project data. And also for the machine learning, we must have a math library. So I install the NUMPy and SCIPy. These are very good library installed in my PySpark. And then next is create a feature vectors for decision tree model. Before I do this, the first thing I need to transform all categorical features into vector forms. So in my data, the unemployment rate and GDP growth are the categorical features. So I need to transfer them into vector forms. For unemployment rate, if the rate is less than 5%, I use 0. And if it's between 5% to 10%, I use 1. If it's larger than 10%, I use 2. The same for the GDP growth. If the GDP growth rate is between 2% to 4%, I use 0, and 0% to 2% use 2, and 4% to 6% use 1, less than 0 use 3. So once I have this, and then I can start to create feature vectors for my decision tree model. The target variable is new household, and the features, numerical features is population, 15-year interest rates, and 30-year interest rate HPL and household. And the categorical features is unemployment rates, GDP growth. And this is my script in PySpark. So I extracted the mappings to convert the categorical features into binary encoded feature, and then create the functions to apply to each record. Also, I create a function to extract a target variable from each record. So once I did this, and this is my data for model, this is the first row of my data. So once I have all the data, I will select 10% of the data for the testing and 90% of the data for the modeling. And I use the random split function to split the data randomly. And then I start to use this 90% of data to build the decision tree model. The first step is import decision tree module. Use from PySpark.ml-library.tree import decision tree. And next is the training the decision tree model by using train regressor method. So this is my model, and then the output, the predictions, the predictor. I use this predictor function, and then compare the actual with predicted number, and print the results. So here are the results. It gives me the actual numbers and the predicted numbers. And then the evaluating the performance of model. So I use the mean squared error, root mean squared error, mean absolute error to measure the performance of the model. So we can see from the results, the mean squared error is 103 million, and the mean absolute error is 8,000, and root mean squared error, squared log error is 0.1843. So looking these results, from these results, we can see our decision tree model performance is good, and then we can save our model. So I can show you the model where I saved my model, final project. So these are all my output results I saved here in my final project, and I export the data to my local drive, and then local desktop, and then I will do the visualization in R by using load the results into the R. So this is my R script. and then plot the relationship between my target variable as the new household with each economic factors. So from the picture we can see all the relations between these. And then okay, and we need to type the library here. library. Okay, once we have this, and we do this, and then we can run all these results, and we can see the decision tree in R, and it's very clear to see all the decision rules to predict the new home field. Okay, this one is the new actual sales versus the predicted sales. It's also in our link. But okay. Okay, and you can see. Okay, so this is our pictures for the actual versus predicted. So now we have done all our work. Are all done, and the summary is: decision tree model creates a visual representations of all possible outcomes, which is good to be used in big data mining, especially for categorical variables. And the second is so decision tree actually is very good big data tools to do the modeling. And the second is understand and clean data is very important during this model process. And every time when I have errors come, I will go to check my data, and the data they will have some missing, or they are use different format, so you cannot combine them together. So all the many errors I have is all about the data is not very clean, and so I think this is a very important step in doing this big data project, big data model. So, okay, so this is all my work. Thank you.